हेलो एवरीवन, कैसे हो आप सभी लोग। आई होप सब अच्छे होंगे। सो टुडे आई एम बैक अगेन विद अ वीडियो लेक्चर ऑन द टॉपिक ऑफ वेक्टर्स एंड 3D ज्योमेट्री। सो टुडे विल बेसिकली द लेक्चर विल बी ऑन द कंटिन्यूशन विद द लास्ट लेक्चर। तो लास्ट लेक्चर में हम लोग अलजेब्रा ऑफ वेक्टर्स को पूरी कंप्लीट कर चुके थे। तो टुडेस लेक्चर विल बेसिकली कंटिन्यूशन ऑन द टॉपिक ऑफ वेक्टर्स एंड 3D ज्योमेट्री फ्रॉम द लास्ट लेक्चर व्हाट वी आर स्टडीड on the properties as well as the topics of coplanarity, collinear points, linearly dependence and linear independence. And today our lecture is basically on the continuation and we study about some important remarks based on the topic of the previous topics. Okay, so today's remark will be very useful. अगर आप remarks को याद रख लोगे तो question solving में help आएगा. And then we move on to study about the other properties also. ठीक है, तो शुरू करते हैं लेक्चर के साथ। तो माय नेम इज सिरशा एंड आई एम बीटेक स्टूडेंट एट IIT खड़गपुर। सो this will be the basically today's goal. So today's goal is basically on the properties of algebra vectors, and then we move on to study of the scalar product, and then we move on to study of some basic questions. Okay, so शुरू करते हैं आज का lecture. So now basically before starting on the lecture I want to take up some remarks or important point. Now these important points I want all of you to write these points important. Okay, आप लोग काम करो, जहाँ पर नोट्स लिख रहे थे ना उस नोट्स में ये सब पॉइंट्स को इंक्लूड कर लो. सो टुडे आई कैन बी बेसिकली स्ट्रेसिंग अपॉन दिस पर्टिकुलर पॉइंट्स टू रिमेंबर. ओके, ना यू मस्ट रिमेंबर दिस पर्टिकुलर पॉइंट्स. तो मैं हर एक लेक्चर के ना साथ साथ ये सब ऐसे पॉइंट्स लाते रहूँगा ताकि आपको बेटर अंडरस्टैंडिंग हो, या फिर कोई पर्टिकुलर शॉर्ट ट्रिक या फिर कोई ऐसा कुछ मिल जाए तो मैं उसको मैं दिखाने वाला हूँ. ठीक है, सो विद दिस लेट्स गेट स्टार्टेड एंड try to understand this particular properties. So सबसे पहले जो point है that is basically a vector is a physical quantity. So basically vector is a physical quantity that has both magnitude as well as direction, and we also studied that vectors means ऐसा कोई quantity है जिसका direction और magnitude है उसको vector directly नहीं बोलेंगे. It should also satisfy the vectors property of addition. Okay, then we move on to study this particular thing. The second property says that if a vector, b vector and c vector, three vectors represented by the side of a triangle, then which are taken in order, then in this particular case, okay, in that case we say that a vector plus b vector plus c vector is equal to null vector. I hope this particular point is clear. Now conversely I can also say that if the three vectors are collinear vectors, if three vectors are collinear vectors such that a vector plus b vector plus c vector is equal to null vector, then they form the sides of a triangle. I hope this particular point is clear. Now this was basically clear in continuation with the triangle law of vector addition. We already studied this particular law that whenever we take the vectors in order in this fashion such that all the vectors are in this order, that they are forming a loop. Okay, in that case if this is vector A, if this is vector B and if this is vector C, then I can say from here that these three vectors are collinear and these vectors form the sides of a triangle such that their addition, the sum of all the vectors is basically equal to null vector. Okay, so now let's move on the third property. And third property basically says that two null vector, okay, two non-zero vectors, okay, two non-zero vectors a vector and b vector are collinear, are given as collinear if and only if there exist two non-zero scalars x and y such that then x a vector plus y b vector is equal to null vector, and both of them are collinear vectors. That means there exists a linear relation between these both the vectors. Now similar to this, if I saw on the fourth point it is mentioned that if a vector and b vector are two non-zero non-collinear vectors, then in that particular case if there is a vector relation existing in this particular fashion, then I can directly go on and say that x equal to y equal to 0. So if they are non-collinear, then I can directly say this particular condition. I hope you are taking notes of this particular thing. Secondly, the fifth property. Okay, let us study the fifth property. Fifth property says that the a vector and b vector are two non-zero vectors. Then the vector r vector, if it is coplanar with a vector and b vector, then r can be expressed as in this particular fashion. If this r vector is coplanar with a vector and b vector, then I can represent r vector as some linear relation or linear combination of a vector and b vector. Okay, I hope this particular point is clear. Now similarly this particular point can also be written as, now x, this is basically the projection of, we can also write in terms of projection of x on a times of a unit cap and projection of y on b in times of b cap. This is how in result, this is for example if you are having this particular vector which is coplanar with these two vectors. I already talked about this particular point in the previous lecture that if this r vector is basically coplanar, then I can write this r vector as sum of this a vector and b vector in such fashion that if a r vector का जो projection आने वाला that on the a vector times the a vector का unit cap plus r vector का projection on the b vector times the b cap. Okay, in that particular fashion I can express r vector as summation of a vector and b vector. Now ये वाला जो point है ये काफ़ी handy होगा जब आप question solve कर रहे होगे. I hope this particular point is clear, and we also took up some question in the last class to illustrate upon this particular fact. Okay, so if I see and move on to the next particular properties. Okay, so the sixth property basically talks about if there is a vector A, B and C are the three given vectors which are non-coplanar, these are basically non-coplanar vectors, then every vector R in space can be uniquely expressed as this particular linear combination of A, B and C vector. So if there is a R vector which is non-coplanar, in that particular situation, then I can uniquely represent R vector as the linear combination of A, B and C vector for some scalar x, y, z. Now here the vectors x a cap, x times of A vector, y times of B vector and z times of C vector are the compound of the R in the direction A vector, B vector and C vector respectively, and the scalars the x, y, z are known as the coordinate of R vector related to the triad of non-coplanar vectors A, B, C. The triad of non-coplanar vector related to which we decompose any vector is basically called the base. Now these are basically theoretical understanding, पढ़ना चाहते हो पढ़ सकते हो, नहीं तो skip भी कर सकते हो, कोई basically उतना ज़्यादा important नहीं है, ठीक है. Important वही है कि अगर तीन नॉन कोप्लेनर वेक्टर दे रखा है तो R वेक्टर है, then that particular vector can be uniquely expressed as linear combination of A, B and C vector. That is very important. And similarly R vector can also be written as projection of that particular R vector on A vector times A cap plus projection of on Y of projection of R on B times of B cap, projection of R on C times of C cap. Okay, this particular fashion we can express that R vector also. Okay, so with this let us move to the seventh property. The seventh property has to say, okay, then seventh property says that if A vector and B vector C vector are basically three non-zero non-coplanar vector and then they are represented by this particular relation, the vector relation exists and is equal to null vector. In that particular situation, this particular case only exists when all of them individual component or the coefficient are equal to 0. All of their individual components or coefficient are equal to 0. Now let us move to the eighth property. The eighth property says that a set of non-zero vectors A1 vector, A2 vector and A3 vector and An vector are linearly independent. In that particular case also, if their vector relation exists and equal to 0 vector or null vector, then in that particular fashion all the scalars are equal to 0. Now again, if I say that there is a linear relation between them, then there exists a scalar which are not all are 0. Then there exists a linear scalar of which of not all of them are 0. Okay, if there is a linearly dependent relation exists. Okay, in linear independent all of the scalars are 0. In linear dependent relation all of the scalars are not all 0. Any two non-zero non-coplanar vectors are linearly independent is very true. Non-collinear vectors are always linearly independent. Similarly, any two non-collinear vectors are always linearly dependent. Obviously there exists a linear dependent relation. Any three non-coplanar vectors are linearly independent. Similarly, if three vectors are given and they are non-coplanar, then they obviously are linearly independent. That means that there doesn't exist a linear relation between these vectors. Similarly, any three coplanar vectors are always linearly dependent. Similarly, any set of 4 or more vectors in three-dimensional space is linearly dependent set. Okay. Now, on this particular point also, I will stress in the upcoming points. Okay. So, in ninth property says that if there are vectors A and B which are 2 points with the position vector A vector and B vector respectively, then the position vector of this particular point dividing the line AB in the ratio m:2n, then I can write this section formula relation which we already studied, internal relation and external relation, result as this. Similarly, if there are two vectors with position vector A vector and B vector and m and n are in the positive real numbers, then I can also express this particular thing as this way. This is basically the result which obtained from the section formula. Okay, so it also talks about the midpoint formula. I hope you will see this particular thing. Similarly, if in a triangle is given, and I already talked about this particular point. Okay, in a triangle, the centroid, if I have this in a triangle, all the position vectors are represented as A vector, position vector of point B is represented as B vector, and position vector of point C is represented as C vector. Then I can write the position vector of point G. Then I can write the position vector of point G as A vector plus B vector plus C vector whole divided by 3. I hope this particular relation was clear from the last class only. Similarly, there is a necessary sufficient condition for 3 points with the position vector ABC to be collinear. If there are 3 points and they are collinear and there exists a vector relation like this, x times of A vector plus y times of B vector plus z times of C vector is equal to null vector in that particular situation, then this particular case obviously exists, that x plus y plus z is equal to 0. So then only then they can be collinear. Now on based on this there can be questions framed in the examination. I hope you will take care of this particular point. अगर collinear का condition अगर तीन vectors का collinear condition पूछ रहा है, तो similarly coplanar का condition पूछेंगे with 4 vectors. Okay, to be coplanar, then there exists this particular relation where x, y plus z plus t is basically equal to 0. I hope आप ये सब results आपका याद रखोगे, ठीक है, and these results will come very handy when you basically go on and try out some questions, ठीक है. तो ये काफ़ी ज़्यादा 2 points काफ़ी ज़्यादा useful है, ठीक है. I hope these particular points are clear. So with this let us start and let us see some examples. Okay. Now the first example that I will take basically will be some on the basically on the properties of or the algebra of vectors. Okay, the very first question I am taking basically in this question it says that if A, B, C is a parallelogram, So in this question it is said that ABC is a parallelogram, and while AC and BD are the diagonals. Okay, it is mentioned in the question when AC and BD are basically diagonals, then I have to find the result that AC vector minus of BD vector. I have to find this particular result. So if I go on and see by the simple triangular law of addition or parallelogram, you can use the parallelogram law of addition over here. So if I go on and see, so if I make a parallelogram complete like this is A, this is B, okay, this is C, this is D, and this is AB vector, this is BC vector. So what I am given with, we are given with the AC vector. AC vector is given to us like this, and similarly BD vector is also given. So BD vector will basically pointing towards D. So this is BD vector. We have to find out the difference of this AC vector and BD vector. So करेंगे कैसे करेंगे? तो for example, if we want to solve this question, let me assume कि मैं AB को let कर रहा हूँ, ठीक है? By letting, let AB vector be basically equal to A vector, and similarly I am letting also BC vector. Okay, I am letting this BC vector as some vector, and let this vector is B vector. Okay, so from here what I can go on and write and say that AC vector is basically equal to A vector plus B vector by parallelogram law of vector addition. Okay, so if I label it as first equation, and similarly again, okay, if I go on again and solve, what I see from, if I apply this particular, if this particular vector is BC vector as B vector, I can write this AD vector also as B vector, because opposite sides of a parallelogram are equal and there are parallel sides, so the direction will be also equal and magnitude also equal, so this is also a B vector. So from here I can make a comment that I can add AB vector plus BD vector, which is basically equal to AD vector by triangle law of addition, triangle addition law. Okay, so if I write this particular result, and then can I write the BD vector basically as B vector minus of A vector, can I write this and label it second equation? Then from the question we actually have to calculate AC vector minus of BD vector. Now from here if we calculate the answer, then it basically will be AC vector is A plus B vector, okay, minus of B vector minus of A vector, and this is basically equal to 2 times of A vector. The result of this question is basically 2 times of A vector. I hope this particular discussion is clear. So this type of question will be seen in the examination purpose. Okay, you will have to see some question will be based on this particular fact on the triangle law of addition and concepts on this. Okay, so with this let us move on to another and take one more important example basically on the vectors. Okay, basically on the this particular properties of vectors. Okay, so if I take this particular question in this fashion, okay, we talked about this particular questions types. Okay, now these types of question will basically those questions which are actually coming up frequently in the examination situation. Okay, even you will encounter this type of question in your CBSE board examination as well. So this particular question says about that there is a vector which is C vector, and it is directed is along vector A vector is along the, sorry, it is along the angle bisector of A vector, and A vector is represented as 7i cap minus 4j cap plus of, sorry, it is minus of 4k cap, and we are also given with another vector that is B vector as minus of 2i cap minus of j cap plus 2 times of k cap. Okay, now from here also we are also given with a condition that is modulus of c का जो value है that is also given also as 5√6. So in this particular question we already saw that कोई vector का अगर angle bisector के terms में represent करना है, then we have to take the unit vector and make this particular vector also as unit vector. Without making this vector as unit vector we cannot find the angle bisector. So सबसे पहले क्या करना है, अगर मैं c का unit vector निकाल जाऊँ, c unit vector, that is basically will be equal to a unit vector plus b unit vector whole divided by modulus of these particular vectors. Okay, by divided by modulus of this particular vector. So if I go on and write the a unit vector and b unit vector, what can I write? Can I write this as a unit vector is basically vector A divided by modulus of A? Can I go on and write this? And if you solve this, okay, also you can write one important result also regarding if you are actually given with the thing, actually here in the question it is also mentioned about the magnitude, so we don't have to worry about basically about this particular denominator terms. Okay, so I can also write this particular vector as basically lambda times of a unit cap plus b ka unit cap, because this lambda will encounter for all the values when I will put the basically the magnitude of c vector is basically equal to 5 root 6. So if I go on and compute this particular result as lambda c is equal to lambda times of a ka unit cap plus b ka unit cap, you can go on and solve this particular question. But if I say that the magnitude is given to us and I can encounter this particular, instead of solving this particular more number of calculation will be involved, and instead of that I can directly replace with the lambda, and such that lambda will incorporate for the magnitude value. So in that particular fashion I can write this, and if I go on and see, the modulus of a will basically equal to, modulus of a will basically 49 plus 16 plus 16, that is basically root 18 1, that is 9. And similarly modulus of b will basically be equal to this is basically 4 plus 4 8 plus 1, that is basically 3 root under 9, that is 3. So from here I can go on and write 1 by 9 times of 7 I cap plus 4 j cap minus 4 j cap minus 4 k cap, okay, plus of 1 by 3 times of minus of 2 I cap minus of j cap and plus of 2 k cap. Okay, so from here if I solve I will get the result as something as lambda by 9 times of I cap minus 7 times of j cap plus of 2 times of k cap. What I did, I multiplied by 3 over here and the denominator as well, so I get 9 over here, and then I compensate the result. From here I get the result something as this, and this is basically c vector. So if I calculate the c vector ka jo modulus hai, from here if I try to calculate, I will directly take lambda by 9, which is a scalar value. So if I square and add then also I will get the lambda by 9 as common out from the square root value. So if I go on and compute this particular result, that is 1 plus 49 plus 4, what result will I be left with? That is basically 5 root 6. And from here if I solve this particular question, is basically lambda times of this basically how much, 54 basically that is 54 is 9 times of 7. So from here I can write the 3 root basically this will be root under 54 divided by 9, and I can also write this replace, when I am taking modulus I can replace this with the plus minus sign, because I don't know about the sign ratio, because sign will basically be decided with the unit vector. Okay, this particular c unit vector will be deciding the sign of the vectors, okay, the negative or the positive sign. Okay, so from here I can solve this particular equation, and lambda by 9 times of root under 54 basically equal to 5 root 6. So from here I can solve this, lambda is basically equal to plus minus 15. If we go on and solve, the value of lambda will be plus minus 15. So from here you will get the c vector which is asked in the question as something as c vector will be basically equal to plus minus of 15 by 9. Why I am represent plus minus? Because this particular vector can also be like this way, this fashion, because it is nowhere mentioned that it is along the internal angle bisector or along the external angle bisector. But in the fashion, if I say this is along the internal angle bisector, then in that particular case you will assume this particular vector only. If I say that the question asks only for internal bisector, then you will assume this particular vector and simultaneously you will use a plus sign. Okay, I hope this particular situation is clear, and with this you will get 5 by 19 times of I cap minus of 7 times of j cap plus of 2 times of k cap. So I hope this particular result is clear. So on this we got to the result of c vector. Okay, so with this we come to the end to the properties of the algebra vectors, and with this we move on to the another important topic, which is on the basically on the scalar product of vectors. Okay, so what is meant by scalar product of vectors? Now what we studied till now was basically addition and subtraction of vectors and the properties regarding to it. So if I want to say that can vectors be added, yes, the answer is yes. So similarly, can vectors be multiplied? So when you are multiply vector, there can be two ways of multiplication of vector, that is basically that is scalar product, and one is dot product, that is also known as dot product, and another is cross product or vector product. So scalar product always result to the result is scalar, so the result is scalar value. Okay, similarly if we perform the cross product, which we will take in the upcoming class, then the result will be a vector value. So what is known as a scalar product? So for example, if I am having two vectors, such that this is a vector and this is b vector, such that the angle between the two vectors are basically theta. Okay, we are given with the angle between the two vector. अब angle between the two vector कैसे निकालते हैं इसके ऊपर चर्चा करने वाले हैं, ठीक है. तो अगर मेरे पास कोई दो vectors है, for example this and this is a vector and another vector is given something like this, तो for taking out the for calculating the angle दो चीज़ें आपको मेंटेन करना पड़ेगा, ठीक है. कोई भी एक करो, ठीक है, मैं बेसिकली वही बोलता हूँ कि कोई भी एक करो, ठीक है. बेसिकली क्या करना पड़ेगा, either you join both the tails of the vectors and then find out the angle, and the angle which is basically the less than 180 degree. Okay, so if I go on and join, and similarly you can also do one more thing, that you can join the heads and take the angle between them, and the angle should be 180 से छोटा, ठीक है. I will explain this. So for example, if I am given with the b vector something like this, can I take this vector and move over here such that the b vector is the tail of the b vector and tail of a vector coincides, and then this vector is a vector, then I can have two angles between these vectors. Okay, now one can be this particular angle and another angle can be this particular angle between the vectors. If I say the angle between the vectors, you can say me which angle are you talking about? There is two ways of possible of taking an angle, that is basically this particular theta and this basically the 2 pi minus theta. So what should be the angle between two vectors? So according to the definition of the property, the angle which is 180, which is less than 180 degree, the angle which is less than 180 degree should be the angle considered for the vector, okay, for that particular vector, for that angle between the vectors. Okay, so the angle which is basically less than the 180 degree should be considered as the angle between the two vectors. I hope this particular discussion is clear. Now in this particular situation, if I say that there is vector A and similarly vector B such that the angle between the two vectors is basically theta, the angle between the vectors is basically the less than the smaller angle, the smaller angle is theta, then I can go on and define a product, and the scalar product which is defined as A vector dot B vector. This dot represents scalar product or dot product will basically equal to the result, that is basically modulus of A vector into modulus of B vector, and here it is into means the simple algebraic multiplication times of cos of theta. The cos theta will be this theta and cos of theta. So from here you get the important result, that is basically known as the scalar product, that is basically A dot B is basically equal to modulus of A times modulus of B times of cos theta. So in this case, if both of the A vector or any of the if any of the A vector or B vector or both of them are 0 vector, then in particular result we get the result of the scalar product is 0. And similarly, if theta is also 1 pi by 2, that is 90 degree, then also we get the result which is known as 0. Okay, that is 0. So in this particular situation, so the most important use case of basically scalar product is basically to calculate this particular theta value. कि क्वेश्चन में क्या होगा ना, सिमिलरली यू विल ऑल्सो ना, क्वेश्चन में क्या होने वाला पता है आपको, दो वेक्टर्स दे दिया जाएगा एंड यू हैव टू फाइंड आउट द एंगल बिटवीन द टू वेक्टर्स. नाउ व्हेनेवर देयर इज इन्वॉल्वड टर्म्स कॉल्ड एंगल बिटवीन द टू वेक्टर, यू हैव टू कैलकुलेट द डॉट प्रोडक्ट, एंड फ्रॉम द डॉट प्रोडक्ट you will basically get to the angle between the two vectors. I hope this discussion is clear. So again, if I say that there is a vector which is A and it is represented as some in times of component a1 I cap, a2 j cap and plus a3 k cap, and similarly another vector b vector b1 I cap plus b2 j cap plus b3 k cap. Now from here if I compute the a dot b, now you will say what will be the result. Now from here I can get the result, you will basically multiply the individual, that is I k component I k से multiply करो, because if I multiply I times of j, you will get the result as something which is very 0. Okay, आपको क्या मिलने वाला है, 0 मिलने वाला है. ठीक है, क्यों 0 मिलना है, because the angle between I vector I cap and j cap is basically equal to 0. Okay, basically equal to pi by 2, sorry, and cos of pi by 2 is basically 0. So the result I cap dot j cap is basically equal to 0. So similarly, if you compute the dot product of these vectors and if you simultaneously multiply a1 with b2, then you will get I cap dot j cap, which is basically equal to 0. Similarly, if you compute this result, that is I cap dot I cap, the result will be basically 1, because modulus of I cap is 1, modulus of I cap is 1, and cos of theta that comes out to 1, because theta is basically 0 over here. In this particular case, theta is pi by 2, so you get the result as 0. In this particular case, the theta is 0, so cos of theta is basically 1, and I cap ka modulus and j cap ka modulus and I cap modulus is 1. So from here you get the dot product value as 1, sorry. Okay, so from here you get the 1, and similarly if you compute these results of the dot product in this component fashion, then you will get a1 times of b1 plus a2 times of b2 plus a3 times of b3. So this particular result seems very simple. If you, this is basically multiplying the individual component and adding them all together, multiplying all the individual component and then you add them. Okay, so multiply the individual component and then add them. So what does basically scalar product geometrically means? So the geometrical significance we will talk about now. Geometrical interpretation. So what will be the geometrical interpretation of this dot product? So if I go on and say the dot product gives us an important quantity that is known as the component times. Okay, now in the last class also I have discussed the projection concept of projection of vectors on another vector. So basically if I have a vector like this fashion, that is a vector and this is b vector, okay, b vector as something like this, and the angle between the vector is b theta, then can I take the projection of this vector on a vector, and which will basically this particular length. Similarly if I go on and compute the projection on this particular vector, this will basically if I take the projection of this particular vector, this is basically dropping a perpendicular, Okay, so this is basically equivalent to dropping a perpendicular over here. Don't get confused the diagram. Okay, this is basically equal to dropping a perpendicular and taking the value of the length over there. Okay, and from here you will say this is basically the projection of A vector on B vector. So what important result can I say about this? Basically is equal to, for example, if I, and here I can write A vector dot B vector is basically as A vector ka mod B vector ka mod times of cos of theta. So can I write B cos theta is basically this particular length. If this length is L parallel, can I say this particular length as B cos theta? So if I say this length is B cos theta, this particular length is B cos theta, then can you say me that this is A vector ka modulus times of projection of B vector on A vector? Okay, now similarly you can also write this as modulus of A vector times of cos of theta in times of B vector. Now this basically result will be also implying the important thing, that is basically also known as the projection of A vector on B vector times the modulus of B vector. Can you say me that this is also A dot B vector? Because if you see this result, this is basically angle is pi by 2 minus of theta, because this angle is pi by 2. So in the triangle, if sum of the triangle angle in the triangle is basically equal to pi by pi, so from here you get this angle as pi by 2 minus theta. So from here if you say what is this length, you will say that this particular length अगर मेरे पास इस length का value है modulus of A vector, then if you go on and compute this particular length will be modulus of A ka cos theta. Okay, so and again this particular length is modulus of B, then this particular length, this total length will basically be equal to the modulus of B ka cos theta. So I hope this particular result is clear. So basically the geometrical interpretation of scalar product of any two vector is basically the product of the modulus of either vector times the projection of the other vector on this particular direction. Okay, on its direction. ठीक है, फिर से मैं रिपीट करूँगा. Okay, so here this is basically projection of, so geometrical interpretation is basically projection of A vector on B vector times the projection basically will be a scalar value, projection of A vector on B vector times the modulus of this vector. Similarly, if I go on and say you one important thing, that if I have two vector, the projection of A vector on B vector. Now this language should be very clear, and this is the most important types of question that you will face in the examination based on scalar product, the most important property. So if I have to ask and understand what is the projection of A vector on B vector, what will you say? You compute the dot product between these two vectors. अब क्या करना, डायरेक्टली आप दोनों वेक्टर का डॉट प्रोडक्ट कैलकुलेट करना है एंड डिवाइड बाय, किसको डिवाइड करना है, जिसके ऊपर प्रोजेक्शन फेंक रहे हो, सो इन दिस केस A vector is projected on B vector, so we have to divide by the modulus of B vector. I hope this particular result is clear. So if this projection length is D, then this particular result will be A times A vector dot product with B vector divided by modulus of B vector, because the A vector is projected on B vector. I hope this particular result is clear. Okay, so with this let us move on to some important properties about regarding the scalar products. Okay, regarding scalar products. So if I write this as note, now important note, this will be helping in solving of questions. So for any two vectors, if the vectors are given as A vector and B vector, so अब स्केलर प्रोडक्ट कब अप्लाई करना क्वेश्चन में, कैसे पता चलेगा स्केलर प्रोडक्ट लगाना है क्वेश्चन में? जब भी क्वेश्चन में अगर पूछेगा कि यू हैव टू फाइंड द एंगल बिटवीन द वेक्टर, और या फिर वेक्टर का सम देके स्क्वायर कर रहा है, दैट मीन बेसिकली स्क्वायरिंग अ वेक्टर कैसे कर रहा है, ठीक है, दैट इज बेसिकली इक्वल टू टेकिंग डॉट प्रोडक्ट ऑफ द वेक्टर विद इटसेल्फ ओनली, सिमिलर फॉर स्क्वायर. एंड अगर एंगल बोल रहा है तो देन टेक द डॉट प्रोडक्ट ऑफ टू वेक्टर एंड डिवाइड बाय द मॉडुलस ऑफ द बोथ द वेक्टर्स, देन you will get the cos theta. From there cos theta you can get to the angle of the vectors. Okay, so I will write some important results basically based on this particular important thing, that if I am given like A plus minus of B vector mod ka whole square, if I have the expression something like this, and this particular expression is basically equivalent to taking dot product of these two vectors. Okay, now this particular thing can also be implemented something which is very similar to the rule we studied in basically in the algebra of numbers. Okay, algebra of numbers, I can write this as a times of A, that can be A square, modulus of A square, and if I write A times of B, this is basically A dot B. Similarly this will be A dot B, so over here 2 times of A dot B, and plus minus sign will be introduced over here, because if this particular sign is plus minus and this sign is plus minus. Similarly if you go and compute this will be plus times of modulus of B vector ka whole square. So this result seems similar to that particular formula A plus B ka whole square, where both A and B are real numbers. So I hope this particular result is clear, and you will take this particular result in terms. Okay, so This is very important. Now similarly, another important case is there when two vectors are orthogonal. That means the orthogonal case is there. That means the angle between the two vectors is basically 90 degree, and in that particular situation, I will directly compute the scalar product and I will equal it to 0. So in this case, I can say vector A and vector B are orthogonal vectors. Orthogonal vectors. I hope this particular discussion is clear. Okay. Similar to this particular fashion, you can also write this. You can also write another important conclusion, that is A vector plus B vector plus C vector. Iska whole square will basically means, iska whole square basically means the modulus of this particular vector ka whole square, and this particular thing can also be written as some similar to the result of algebra, can be written as modulus of A vector ka whole square, modulus of B vector ka whole square plus modulus of C vector ka whole square plus 2 times of A vector dot B vector plus B vector dot C vector plus C vector dot A vector. Okay, now this particular result is very true. This is basically true. Why? Now basically the vector the scalar product, okay, scalar product follows commutative law. Okay, commutative law, because vector scalar product, okay, if I take the scalar product of these two vectors, it actually follows commutative law. Okay, commutative law, hence commutative law. So I can write A dot B as equal to B dot A. Now this particular result will, in case of vector product, we will see that this particular result doesn't hold true. So A cross B is not equal to B cross A, because there will be a concept of direction. Both of them might be equal in magnitude, but the direction will be different. We will take up in the upcoming classes. So for now, we already know that the scalar product is basically commutative in nature. That means if you compute A times of B is basically same as B times of A. I hope this particular result is clear. So with this, let us move on and try. Let us understand some of the important use case of basically the use case of scalar product. Okay, so scalar product का जो use case है, that basically to take up the component. Okay, component of vector along perpendicular and parallel direction. तो दिस इज द मोस्ट इंपॉर्टेंट यूज केस ऑफ वेक्टर स्केलर प्रोडक्ट. ओके, द मोस्ट इंपॉर्टेंट यूज केस तो पहले मैं बता दिया था कि एक तो मोस्ट इंपॉर्टेंट यूज केस दिस इज बेसिकली टू सॉल्व द एंगल बिटवीन टू वेक्टर्स. Similarly, the another important use case is basically to solve out the projection, that is basically also can be explained something like this, that is basically a component of vector along the perpendicular and parallel direction. So for example, if I have a vector is A and a vector is given which is B, and I have to represent this B vector as its component along the parallel and perpendicular direction. So from here, what I can go and compute, if I take this angle as theta, this is the angle between two vectors, then I can also write this particular component of B vector as basically B perpendicular vector component, and similarly this particular component of vector which lies on A can be written as B parallel component. So from B parallel and B perpendicular component, and if I form a parallelogram, I can write the result as B vector will basically be equal to B parallel plus B perpendicular vector. Can I write this from parallelogram law of vector addition? Yes. And similarly, if I want to know about if I want to write this particular vector, I can write this particular vector in this particular fashion. This is basically projection of B vector on A vector. I can write this projection of B vector on A vector as A dot B divided by modulus of A, because I am projecting it on A vector. So I can write this as divided by modulus of A vector, okay, and multiplied by A ka unit cap. Can I write it like this? And similarly, I can write from here I can write this parallel component in such fashion, plus of B perpendicular component. Now if this is basically the parallel component of this particular vector, so if I have to write the parallel component, it will give me direct result. This is this particular thing. Okay, now if I say write the perpendicular component of this vector, you will do one important thing, that is basically you will subtract the B vector with this particular quantity, that is basically A dot B vector divided by A vector का modulus times of A unit cap or A cap. So you can also change this particular result and write this as B vector minus of A dot B vector divided by modulus of A vector ka whole square. If you change this particular with A vector by divided by modulus of A vector, then I can write this particular result as B vector minus of A dot B divided by modulus of A ka whole square in times of A vector. So from here you will directly compute the result, which is known as the perpendicular component of the vector, and if you get a perpendicular component, you can easily calculate the magnitude of the perpendicular component, so which will basically the component of the vector and the perpendicular direction. I hope this particular discussion is clear. So with this, let us try and solve out some important questions. So in this particular question, we are given that theta, this is basically theta. Theta is the angle between two unit vector. Now it is specified that there are two unit vector, A vector and B vector, and you have to find out the value of this cos theta by 2. So if I go on, what is given in the question, there are two unit vectors are given. So I can write this unit vector, and if it says that unit vector is written as A cap, and this unit vector is there, which is written as B cap, and this angle between the two unit vectors is basically theta, can I go and I have to calculate this particular this cos theta by 2. So how will I do so? So whenever I said that whenever we have to calculate the angle between two vector, the only result that we will apply will basically the dot product. So if I take a unit vector dot of b unit vector will be basically equal to modulus of a unit vector, that is basically 1, times of modulus of b unit vector, that is basically equal to 1, and into what will you write? You will write this particular thing as cos of theta. Okay, so if I write this particular result as cos of theta, again you can do one important thing from here. If I want to know a unit vector plus b unit vector का modulus का whole square. Now why I want to calculate this particular result? Because basically if you see on the question, the result of this answer is given in terms of a plus b or a minus b. Okay, so if I go on and compute this particular result whole square, is basically you will say is basically multiplying taking a dot product with these vectors. Okay. Similarly, if you go on and solve this, you will get one important thing, that is basically modulus of a vector ka whole square plus modulus of b vector ka whole square plus 2 times of a dot b vector, a unit vector, and if this particular thing is basically 2, 1 plus 1 2, and this is 2 times of cos of theta. So from here, if I take 2 common, I can write this as 1 plus of cos of theta, and from trigonometry we know the most important relation, that is basically cos 2 theta basically equal to cos square theta minus of sin square theta. Now from here you can replace this particular thing as 2 times of cos square theta minus 1 will basically equal to cos 2 theta. So if I take this minus 1 on this particular side, I can write 2 times of cos theta is basically 1 plus cos 2 theta. So if it is given as 1 plus cos theta, I can write this as 2 times of cos square theta by 2. Now from this half angle formula, now this half angle formula comes very handy in different calculations of vectors as well as even integration also. Okay, so from here I will get the result is a cap plus b cap. Okay, the unit vectors modulus ka whole square. So if I have to take, and from here if I take out the result, that is a cap plus b cap, this particular vector you will take square root of both the side, and you can write this particular result as 2 times of cos of theta by 2. And in the question it was asked basically cos of theta by 2 is how much? That is basically half times of a unit vector plus b unit vector. So from this I get to the right answer to the question, that is basically option number D, option number B. So this is the basically right answer to this question. I hope this particular question is clear. Now with this, let us move on to the second question. There's basically in this question we are given with the result, that is modulus of a vector is basically equal to 3, modulus of b vector is basically equal to 4, and modulus of c vector is basically equal to 5. So and we are also given with the condition, that is a vector plus b vector plus c vector is basically equal to null vector. So what is equal to null vector? So what I can do to get out the results? Okay, we have to find out the result for this question was actually we have to find out this question is actually some invalid question. Okay, I guess we have to calculate the value of a vector dot b vector plus b vector dot c vector plus c vector dot a vector. Now this particular value we have to calculate from this particular question. Now in this particular fashion, from this given question, if I go and compute square of these vectors, if I apply square of both the side, then I can write this as a modulus of a ka square plus modulus of b ka square plus modulus of c ka square plus 2 times of the required thing that is asked in the question is basically equal to 0. Can I write this? Because basically when I take the square of vectors, it is basically taking a dot product of the vector with itself only. So similarly, if I found out the required result, which is actually asked to find in the question, basically 1 by 2 times of minus of 3 square, that is basically 9 minus of 16 minus of 25. So from here you will get this is basically minus 25, this is minus 25. Okay, so with this you will get the answer, but I think the question missing out some data. Okay, so I cannot take and write the correct option to this particular question. Okay, so I hope this particular thing is clear. So with this, let us move on to the third particular question, which is similar to the question we already solved out, and you can directly solve the result. You can directly get to the result as a vector dot b vector plus c dot a vector is basically equal to this will basically 1 square plus 2 square 1 square plus 1 square plus 1 square, that is 3 square, 3, that is value is 3, minus of, now basically equal to, and is equal to 0. So 0 minus, so it will coming at 0 minus, okay, from the previous result only, basically 0 minus 3 divided by 2. So from the result will be minus 3 by 2, from here the result will be minus of 3 by 2, and the right answer to this question will basically be, this is not question mark, this is basically a minus sign. With this, the right answer is C, option C. Now let us solve some important question. Now this question was taken from the JEE main previous year questions. Okay, so this is basically JEE main 2023 question only. So we are given with a condition of two, if it is said in the question that O is the origin vector and the position vector of point P is given in such fashion, and A, B and C are also given, and we have to find the projection of OP vector on the vector which is perpendicular to these vectors A, B and AC. So whenever we talk about a vector which is perpendicular to vector, we actually come out with the कैलकुलेशन ऑफ वेक्टर प्रोडक्ट. ना वेक्टर प्रोडक्ट जो कैलकुलेशन है वो मैं इस क्लास में नहीं ले रहा था, ठीक है, बट आई टुक आउट दिस क्वेश्चन जस्ट टू इलस्ट्रेट अपॉन द प्रोजेक्शन कॉन्सेप्ट. ओके, सो अब तक फॉर टाइम बीइंग यू रिमेंबर दिस रिजल्ट, व्हेनेवर वी हैव टू कैलकुलेट अ वेक्टर व्हिच इज परपेंडिकुलर टू बोथ द वेक्टर्स, देन आई हैव टू डायरेक्टली कंप्यूट द बेसिकली द वेक्टर प्रोडक्ट. ओके, दैट इज अ क्रॉस प्रोडक्ट. सो विद दिस यू विल गेट द result which is basically another vector which is basically a vector ab vector cross ac vector इसका क्रॉस प्रोडक्ट, एंड इफ यू टेक दिस पर्टिकुलर वेक्टर and in this particular direction you will get a vector which is perpendicular both the vector. So this vector is perpendicular to a vector and this vector is perpendicular to ac vector as well. So if I try out and solve this question, if I try out from here I can write a vector as, so from a vector can be written as basically position vector of b minus position vector of a. So from here if you solve, position vector of b is basically 2i cap plus 4j cap minus of 2k cap minus of a vector, that is basically minus of 2i cap, okay, plus j cap minus of 3k cap. So from here if you compute this this value is basically 4 times of I cap, and this will be basically plus 3 times of j cap minus 2, this is basically minus 2, and this is plus of k cap. So this will be a vector, and similarly if you calculate AC vector is basically c vector minus of a vector from the concept of position vector. So from here if you compute the result is 4 minus of 4 I cap plus 2 times of j cap minus of k cap minus of 2 times of I cap plus of j cap minus of 3 times of k cap. So from here if we compute the result, this result will basically will be minus of 2 I cap, from here this will be plus of j cap, from here the result is minus k plus of this will plus of 2k cap. So if I have to find the vector which is perpendicular to this vector and I name that vector as d vector, then this particular vector will basically ab vector cross AC vector. Now how to calculate the cross product is basically, you might have studied this particular thing in physics when you have to calculate the moment of force. Okay, so I hope this particular concept was actually clear in physics only. You have to take the determinant value of this particular cross product. For cross product you have to write these vectors in component way and then take the determinant value. So this is 4 3 and 1 over here, and from here minus 2 1 and 2 minus 2 1 and 2. So if I compute this particular result, if I compute the determinant value, so this is basically 6 minus 1, that is basically 5 times of I cap minus of j cap times of 8 minus of minus 2, that is basically plus of 10. So plus k times of k cap times of 4 minus of minus 6 will basically again equal to 10. So from here I will get the result which is 5 I cap minus 10 j cap plus of 10 times of k cap. So this is basically a vector which is perpendicular to the a vector and AC vector. I hope this particular thing is clear. Now what we have to calculate in this question is basically the projection of OP vector on a vector which is perpendicular to a vector and AC vector. Now if it is said, if it is nothing mentioned about what type of vector it is, I don't have to calculate. Do I need to calculate the unit vector of this particular in the fashion? So the D vector is basically perpendicular to the AB and BC vector, and it has sum of its magnitude. But if I say there is an arbitrary vector, then what should I do? I should genuinely have that arbitrary magnitude times the unit vector in that particular perpendicular direction. So but if it is nothing mentioned, I can solve it with D vector only. So what I have to do, I have given with the question, in the question is given me that OP vector का projection लेना है D vector के ऊपर. So if I have to take the projection of this OP vector on D vector, so what is basically OP vector? If I write the OP vector, basically position vector of point P, that is minus I minus 2j cap plus 3k cap minus I cap minus 2j cap plus of 3k cap. So from here you can take the projection. So the projection of OP vector on basically perpendicular to AB vector and AC vector. Okay, AC vector basically perpendicular to the AB vector and AC vector will be basically equal to what is basically OP vector dot D vector और किसके ऊपर प्रोजेक्शन ले रहा है, that is basically D vector, तो उसका मॉड्यूलस से डिवाइड कर दो. So that was what I was talking about it. We don't need to calculate the unit vector because this particular term quantity will take care of the particular unit result. And from here if I compute the result, I will get if I compute the dot product, what I will get, this is minus of 5, this is basically plus of 20, this is basically plus 30. So divided by modulus of D means how much? So if I say the modulus of D basically equal to 200 plus 25 under root, that is basically 15. So divided by 15, from here the result I will get, that is basically the projection का जो value आएगा, that is basically 45 by 15. So from here the answer to this question basically will be how much? That is 3. So with this the correct answer to this question will be basically option number B. I hope this particular question was clear. Okay, so with this let us move on to the last question of the today's lecture. So in this question we are given that in an arc, okay, this question is a very beautifully set question. Okay, so what is given in an arc is basically a part of a circle which subtends an right angle at the center. So there is an arc. So for example, if this is an x and y axis and there is a circle which subtends an arc on this particular fashion such that at the origin it subtends at 90-degree angle. So you can say this is basically a quarter circle. So this is basically a quarter circle which basically subtends 90-degree at the center. So in this particular question it is given that this particular point is, if I say this particular point is P and this particular point is Q, so this is PQ arc, and the midpoint will be basically, and the midpoint of this particular arc is R. The midpoint of this arc is given as a point R, so the midpoint will obviously lie on the angle bisector, line. So this particular angle will basically how much? 45 degree. So if I solve this question, what is given, that basically OP vector is basically given as u vector. This particular vector is given as u vector and OR vector is given to us as v vector, and similarly OQ vector is also given as alpha times of u vector plus beta times of v vector. So from here what result can I conclude, that OQ vector is basically coplanar to OP vector and OQ OR vector, which is basically seen from the question. Now if I have to solve this particular question, how will we approach? So सबसे पहले जो point of thinking होगा इस question को solve करने से पहले, that is basically when I say that this particular two vector, this is OQ vector and OP vector, we basically subtend 90 degree in between them, that means the angle between the two vector is basically 90 degree. अगर angle between the two vector 90 degree होता है तो क्या result apply करोगे, that is orthogonality condition apply करोगे, that is basically the dot product compute करके क्या करोगे, equal to 0 कर दोगे. So from here I will get a very important first equation, that is basically OP vector dot of OQ vector is basically equal to 0. So from here if you compute the dot product, that is basically u vector times of alpha times of u vector plus beta times of v vector is basically equal to 0. From here if you compute the result, that is basically modulus of u ka whole square, because u dot u is basically mod of u ka whole square plus of beta times of u dot v vector. So this is basically 0 vector. So from here I will get an important relation, that is basically, and similarly what can I more on say, that this is basically the modulus of OQ, modulus of OR, modulus of OP vector will be basically equal to similar, because this is basically the radius of a circle. All of them are same and basically they represent the radius of the circle. So if I say the radius is R, so can I write the modulus of this, all these vectors are equal to R. From here if I get the result, I will get the result as alpha times of R square plus beta times of, now u dot v will be how much, so the u dot v will be basically modulus of u into modulus of b into cos of theta. So what is the value of cos of theta, this is basically v vector and this is basically u vector. What is the cos of 45 degree, that is 1 by root 2. So from here you will get the result as r square by root 2, which is equal to 0. So if you solve this and simplify, you will get the result that alpha is equal to minus beta by root 2. Okay, so from here if you compute the another result, that is basically this particular result as u and r and basically this particular thing, okay, u and v. So if you take u dot v, what will you get? So from here if you compute this particular result of u dot v, you will get r square times of 1 by root 2. Okay, so what is actually mentioned in the question is basically you have to find out the relation of these angles, okay, the relation of these particular things. Okay, from this question you have to actually represent the OR vector OQ vector, OQ vector as times of this particular thing. So what I can also go on and do one important thing, that is I can take the dot product of OR vector with OQ vector, and what result will I get? Okay, can I compute this particular dot product? Okay, what will it give me any important result? I don't think so it will give me an important result. So and what second concept that I can use from this particular question can be that V vector is basically around the angle bisector. So from here I can say that the unit vector of V unit vector will basically be along the unit vector of U plus unit vector of OQ vector. Okay, will be along this particular direction only. Okay, along the direction, and divided by the modulus of U vector प्लस OQ वेक्टर का मॉड्यूल यूनिट वेक्टर का दोनों का सम करके मॉड्यूलस करेंगे. ओके, will be like this. Okay, so from here what important result will you get from this question? Now basically this question, now this particular calculation is simply tedious. Okay, simply tedious calculation. So can I write this particular vectors can be represent something like this? So from here if I go on and write this V vector as V vector divided by modulus of V vector, and U vector as U vector divided by modulus of this particular vector, and similarly if this divided by modulus, you will get the result of alpha and beta from here. And what we have to comment on that alpha and beta का value from this particular question. So if I go on and check from the answers, अगर आप ऑप्शन देख के भी एलिमिनेट कर सकोगे ना तो आप क्वेश्चन को कर पाओगे, ठीक है. सो बट इफ यू डोंट वांट टू एलिमिनेट द ऑप्शंस, ओके, एंड वी ट्राई टू सॉल्व दिस पर्टिकुलर क्वेश्चन. So from here if I want to eliminate, okay, so from here if I want to eliminate the value of alpha and beta from here, so we can also write one important thing, that is basically if I take on this particular modulus of OQ vector, okay, modulus of OQ vector. So if I take on the modulus of OQ vector, it will basically equal to R vector, that is basically equal to R, because I said the radius of the circle is R. So from here can I write this as alpha times of U vector plus beta times of V vector का modulus is basically equal to R. Now if I square this both the sides, so basically taking this is basically taking the scalar product of both the sides with the same vector. And similarly if I compute the scalar value, basically alpha square times of U modulus of U का whole square plus beta square times of V modulus का whole square plus alpha beta times of plus 2 times of alpha beta times of U dot V vector. Okay, and this particular thing is equal to R square. Now what do we know, that modulus of U square and modulus of V square, and if you compute this particular vector also it will give me modulus of U square या फिर modulus of V square, because both of them modulus are same and is equal to R square. So from here I can take R square common, this basically, and then I will get the result as R square common, and then I will get the result as 2 times of, from here this will be basically alpha beta into basically 1 by root 2. Okay, so from here this result will be R square. So if I cancel R square and R square from both sides, I will get the result as 1. So from here if I compute alpha square plus, and instead of beta I put beta as, from this first result if I put beta as minus of 2 times of root 2 alpha. So if I compute beta square, then basically 2 times of alpha square, and this particular result will be 2 divided by root 2, and if I play alpha and in place of beta I write it as root 2 times of alpha. So from here root 2 get cancelled, and if it is equal to 1, so from here I will get the result of alpha square is basically equal to 1. So from here the value of alpha can be 1 or minus 1, and similarly beta का जो value होने वाला, that is basically can be root 2 या फिर minus or root 2. If alpha is 1 then beta is root 2, and if alpha is minus 1 then beta is plus of root 2, and if alpha is 1 then beta is minus root 2. But the question says, question में क्या बोला है, is basically alpha and beta square are the roots of which of the following equation. So if from here if I calculate alpha दे रखा है and beta square दे रखा है, okay, beta square will be basically how much, that is basically 2 from both the situation. And similarly what should be the value of alpha. So अगर alpha का value 1 लेंगे या फिर alpha का value minus 1 लेंगे, that can be a controversy in the question. Now आप देखना चाहोगे अगर alpha का value minus 1 लेते हैं ना, then the beta comes as root plus root 2. And in the question if I say that b square is a coefficient, okay, b square basically एक root है, अगर b square का वैल्यू पॉजिटिव आना चाहिए, तो सिमिलरली जो b का वैल्यू है दैट इज बेसिकली इंप्लाइज कि b का वैल्यू भी पॉजिटिव वाला रिजल्ट लेके क्वेश्चन को सॉल्व करना चाहिए. सो फ्रॉम हियर इफ आई टेक द रूट्स एज -1 and 2, so for the result I will get basically x square plus x minus 2 is basically equal to 0. Sorry, minus of x okay, minus of x minus 2 is basically equal to 0. Okay, so from here what I see, okay, if I take like this, so from here what I see that basically the sum of the roots is basically equal to plus 1, okay, and plus 1, and the product of the root is equal to minus 2. So if I take this particular condition, then I can fulfill my situation, because if alpha is equal to 1 and beta square is equal to 2, can I have the product of the roots as minus 2? No. In that particular situation, alpha has to be minus 1 and beta is basically equal to, beta square is basically 2. So from here the right answer, that is basically the equation of whose roots as given as alpha and beta square are basically option number D. So from here you will get the root of this particular question. Okay, so I hope this particular discussion is clear, and which is the right answer to this question is basically option number D. So this particular question is very important question. आपको फिर से इस क्वेश्चन को लगाना है, ठीक है. इन दिस आफ्टर दिस डिस्कशन ऑफ टुडेज लेक्चर आपको इस क्वेश्चन को फिर से लगाना है ऑन योर ओन. ओके, दिस पर्टिकुलर क्वेश्चन केम में जेईई मेंस, ऐसा टाइप का सिमिलर क्वेश्चन काफ़ी बार जेईई मेंस में रिपीट हो चुका है, ठीक है. सो यू विल टेक दिस पर्टिकुलर क्वेश्चन इन माइंड. सो विद दिस आई कम टू द एंड ऑफ द लेक्चर, एंड so before moving on to the other part of the thing, I will want to make clear. okay, so अभी तक एक मैट्रिक्स एंड डिटर्मिनेंट का जो एडवांस जेईई एडवांस का प्रीवियस क्वेश्चन का लेक्चर है वो अभी पेंडिंग है इस चैनल पे, ठीक है. एंड सिमिलरली आई विल बी पुटिंग अप मोर कंटेंट्स ऑन बेसिकली फार्दर कंटेंट ऑफ वेक्टर्स एंड 3D ज्योमेट्री. तो वेक्टर्स एंड 3D ज्योमेट्री काफ़ी आसान टॉपिक है, एंड यू ऑल्सो सॉ दैट मैट्रिक्स एंड डिटर्मिनेंट ऑल्सो वेरी इजी टॉपिक इफ यू आर वेरी फैमिलियर विद द रिजल्ट्स. ओके, अगर आप कैलकुलेशन जल्दी टाइम में कर पाते हो एंड यू आर एबल टू थिंक द रिजल्ट्स इन पर्टिकुलर फैशन, देन यू कैन डेफिनेटली क्रैक द क्वेश्चन ऑफ जेईई मेंस एंड जेईई एडवांस. I hope this particular discussion is clear. So with this I come to the end of the lecture, and if you liked my lecture, you like the video and subscribe to my channel to never miss out in upcoming content. क्योंकि मैं जेईई मेंस और जेईई एडवांस का जो पूरा सिलेबस है मैं इस चैनल पे डालने वाला हूँ. तो दिस पर्टिकुलर मैथमेटिक्स सीरीज ऑफ लेक्चर विल बी बेनिफिशियल फॉर बोथ द CBSE students as who are preparing for class 11th 12th, even preparing for competitive exam like JEE, WB JEE and other state competitive examination. So they can benefit them their same from this particular video lectures. Okay, now along with these lectures you will also get the notes in the description box. So go check out on the notes in the description box and start to solve question, start solving a question to have good amount of practice. Okay, after this question. So with this I take a leave from the today's lecture. Thank you.